524, closing in on the end of Unit 5. So let's go. Graphing logarithmic equations. So we've done exponential equations and a lot of others. And here's another one. This is considered a parent function, something you're going to get familiar with, and you'll get used to it, just like y equals x squared. But right now, we got to dive in. So first of all, f of x equals log of x. I just grabbed a bunch of random, not so random possible x's, and let's just open up the hood and take a look. Well, if I take my calculator and I'm trying to find my corresponding y, I just go log of -6. Well, my calculator is going to say error because this is saying 10 to some power equals -6. That is not happening. And the same thing's true for this. 10 to some power will never give me a negative response. So what does that tell me about my domain? My domain is going to be 0. Well, let's go ahead and type that in. Y equals log of 0. Can I get 10 to some power equals 0? The answer is no. So I shouldn't have put a bracket around that. It should have been parentheses and then all the way to infinity. So really, there's an asymptote right here. There's no graph to the left of that asymptote. You cannot go into the world of negatives, and you cannot have x equals 0. So we throw that out. That's why I've got this little guy sitting there. So if I just type in log of 0.01, we're going to find out what happens really, really close to that asymptote. So we're going to go log 0.01, and I get -2. Now, so that's really, really close, and then it's just down here somewhere. Not touching it, really close. Log of 0.5, enter. -0.3, -0.3. So if I go halfway here, and I go down a third. 1 should be easy. So if I type in a 1, we should be able to do that in our head. 10 to what power is 1? That'd be 0. Anything to the 0 power is 1. You can type it in your calculator, log of 1, but you're going to get 0. So that's 1, 0. That is a very much an anchor spot for these equations. And if I type in a 10, I don't really need to do that. Whoops, this is where the 10 goes, and I'm trying to find y. 10 to the first power is 10. You can type it in your calculator. It's pretty obvious, 10, 1. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that it comes in like this, flatter than that. Comes like that. Oh, and then it just stays very infinitely close to the x equals 0 asymptote. And this just goes up and up and up on a little by little by little by little. We're going to talk more about that in 2 seconds. So we're going to take a look at natural log. We're not going to take a look at it quite like we did this. We're going to take a look at x is 1. So remember, this is the same thing as y equals. And if I spin it around, that's how my brain likes it, I'm going to put a 1 in there and then put y. And so I say, all right, there's an invisible e there. E to what power is 1? Well, this has to be 0, because that's the only way you can raise anything to the power and get 1. So there is this is called, right there, and I forgot to say this, these 2 points are called the locator points, because that point is 100% certain. It's kind of like your anchor point for these graphs. And if I start typing in things like 4 for x, and I go like this, and I take my calculator, let's just do this one. I'm going to go natural log of 4. I get 1.4 approximately. 1.4. So 1, 2, 3, 4. 1.4 would be right about there. And if I typed in, let's go ahead and do the old 0.01 trick just to see what it does really close to the asymptote there. 0.01. And I get -4.6. negative 4.6. So really close, 1, 2, 3, 4, 5, right about here. So just here, here. And as you can see, very, very similar. Once again, the asymptote x equals 0 is there. What's the difference? Well, the natural log simply goes up faster. It really does go down faster too, but you can't really see it. But you can see the natural log goes just up faster than the log log. It's just the way it is. So those are the personalities of each parent function there. Okay, so here's some examples. And this is going back to our basic transformations. They never go away. So let's apply it to our logarithms. So we start with this, and we say, all right, log. We know that our parent function is going to be y equals log of x. So there's our locator point right there for this parent function. We know it's kind of flat looking, and then it comes in like this. Again, not perfect, but we're going for the general idea. What does this do? Well, it's a vertical stretch. So I'm going to do this in blue. So this point doesn't move in this case. The vertical stretch is just going to have it go up faster, and it's going to actually go down faster, but you're going to have a hard time seeing the difference in here because it's just so similar. And then they're going to ask you some questions. What's the domain? Well, it doesn't quite get to 0, but it goes on for infinity. Range? Well, it goes down to negative infinity, and it doesn't go up very fast, but it does get up to infinity over an eternal time. Locator, 1, 0. Asymptote, x equals 1. That's true for this, and it's true for this. Because all it did was stretch the red one. Now let's move on to this natural log one. Well, remember, y equals the natural log of x is slightly different. There's our locator for this. It goes up faster, but over here is very similar. And you guys should be pretty good at this. Left 4, up 1. That's why this is called a locator point, because you move this. Everything else is, you're not going to really mentally lock into that. But this one, I move left 4, 1, 2, 3, 4. And then I'm going to move up 1. And then and here's the tricky part. The asymptote also moves. So that asymptote needs to move left 4 with it. So it was here. So 1, 2, 3, 4, and that's like my new y-axis. And so now I'm going to try to duplicate this, and it's going to come in like this. Just try to duplicate it, and that's going to come in like that. So I'm just doing my best to imitate it with a different locator point. Okay? So what are all these connected to here? Well, let's go ahead and erase this. And let's go down the list. Domain. Well, my asymptote, let's start with that, because we should. X equals negative 4. The locator point is negative. Boy, did I screw that up? I did. Wait, no, I didn't. 1, 2, 3. Okay. All right. So that is x equals negative 4. I already said it. Panicking now. This is negative 3. 1. What's the range? Well, it goes down and it goes up. So it's negative infinity all the way to positive infinity. What's the domain? Well, be careful with this. It's trying to get to negative 4, but it can't get there. And then it goes to the right forever. So there's some transformation in relation to your log functions. All right. Couple more things. Now we're just going to practice some more of these solving equations using logarithms. Start with this one. Common basis, happy places, not happening. So how in the world are you going to figure that out? Slap a log on that side. Slap a log on that side. Remember what we can do here. We can actually bring that into the front here. Yeah. Okay, geez, mental blank, another one. 3.95 times the log of x equals log 4. So what I'm going to do is divide this side by 3.95, gone. Divide that by 3.95. This thing is cleaning up a bit. And now I'm going to use my calculator just to get a decimal over here. And I get log of 4, enter, divided by 3.95, 0.152. Well, how are we going to figure that out? Well, there's an invisible 10 there, so 10 to the 0.152 power equals x. This is where we're going to use our handy-dandy calculator. 10 to the 0.152 power, I know that's weird, 1.42, approximately 1.42. Weird. Got this problem. I see that e. Slap a natural log on that side. Slap a natural log on this side. Bring that in the front. So I get x times what? Well, natural log of e is 1. Then I go natural log for 20. And I get 6.04. So x is approximately 6.04. How about this one? Subtract 6, subtract 6. E to the x minus 1 power equals 94. Because of that e, we slap a natural log, not an log log, because that works out so much better. You slap a natural log there. Take the exponent, put it in the front. So we technically get x minus 1, natural log of e is 1, so that's just x minus 1 equals, I'm just going to take the natural log of 94, 4.54. Now I got to add 1, so I get 5.54. So after you do a few of these, you can see the rhythm, and they're not that bad. All right.